So let's start with introductions. We'll start here at the Alaska Natural Heritage Program at UAA. This is Monica McTeague helping with general project coordination.
And this is Justin Fulkerson with the Alaska Natural Heritage Program.
This is Becky. I'm the aquatics lead, and I'll be presenting today.
All right, so we'll just do a round robin of those on the phone. So is that you, Cindy, again, from your iPad?
It is. Sorry, I can't figure out how to change the name.
Okay, well, that's okay. Now I know your icons. All right, thanks for joining us again. And Eric, are you with us again?
Yep, Eric Geisler, the Vegetation and Soils Lead from BLM, Alaska State Office.
Great, thanks for joining us again. Jen, are you on the phone?
Yeah, this is Jen Schmidt from CYR.
Hey, Jen, thanks for joining us. Jessica Reimer, are you on the phone?
Yes, I am.
Hi, Jess. She's Alaska Natural Heritage Program.
Oh, sorry. She's a zoologist at the Alaska Natural Heritage Program.
She's the terrestrial fine filter, the species lead. And John, are you on the phone again?
I am. John DeLapp, Northwest Boreal LCC.
Great, thanks for joining us. And again, he mentioned earlier Amanda would be joining us, but she is out of town this week. And then Nancy, are you on the phone, or other folks from SNAP?
This is Angie at SNAP. This is Nancy at SNAP.
And Lena at SNAP.
Great, thank you guys for joining us again, and great webinar this morning. And then Tina, are you on the phone?
Yep, Tina Boucher, Alaska Natural Heritage Program, terrestrial coarse filter conservation element lead.
Yep, she'll be giving her presentation tomorrow. So, okay, with that, did anybody else join us that I didn't see on the webinar? All right, well, I'll go ahead and hand over.
Hey, Monica, real quick.
Yeah.
Bob Carlin is trying to call in. He's having some technical difficulties getting the WebEx to load on his computer, so he's taking my iPad, and I'm going to log in on my machine. But he'll be joining momentarily.
Okay. Do you want us to wait just a minute?
Yeah, we can. Yeah, I think that'd be good. Let's wait for Bob, if folks don't mind.
The pressure's on. Let's see how long it takes him to walk back to his desk.
Has anybody thought of any additional questions for Nancy or her group at SNAP from this morning's presentation? Anything? Come to them over lunch? Okay. All right. Well, if it does, I know she's willing to field questions, right, Nancy?
Yep, we're standing by, happy to field any questions that popped into anyone's head.
Okay. All right.
I have a question, Nancy, while we're sitting here. So if I remember right, you were saying that the projected winter increases in precipitation, when you were breaking it out by fraction, it was most noticeable for rain but not snow. Is that right?
Yeah, I mean, basically there are increases in precipitation, very slight increases projected throughout the year, but when you break it out into rain versus snow, because of the warming, the real increases are in rain because of the shifts in the colder season. So it's not that there isn't more precipitation through the fall, winter, and spring months. It's just that when you add it all up, snow doesn't really increase and rain does because of the additional warming factor.
Okay.
Let Bob on too.
Okay. Bob, are you there? Bob Carlin? Bob, is that you?
It is.
Okay, great. I think you are our last one to tune in. This is Becky.
Hi, good afternoon.
Actually, Shelley, did you join us as well? Looks like she's on there as well. That's Shelley Jacobson in the Central Yukon Field Office.
Okay, well, this is Becky. I'm going to go ahead and get started. It does look like we have a few more additions. That's great. So I'm taking over. This REA was originally being led in terms of aquatics by Leah Kenny, but unfortunately she's moved on to Fish and Wildlife Service. So I've stepped in to help with the distribution models and then work on the integrated products as we move forward. So I'm going to start with the aquatic course filter conservation elements. These are the habitats that were selected by working with the AMT. There are 4 aquatic course filter habitats: large connected lakes, small connected lakes, and then the stream network was split into rivers and large streams and small streams. This is a map showing the connected large lake distribution, and unfortunately, lakes are really hard to see just generally at this kind of scale, so I've got a zoomed-in inset map for lakes in the Selawik area. Large connected lakes were defined as lakes or ponds from the National Hydrography data set that were greater than 0.1 square kilometers that were connected to the NHD flow line feature class. So connected lakes that are greater than 0.1 square kilometers. There are over 5,000 in the study area, and the largest 2 lakes were Selawik Lake and Inland Lake. And those are both in the Selawik watershed. I've got highlighted on here the USGS Lake District. So this is a publication by Chris Arp and Ben Jones where they identified areas in Alaska that have higher density or frequency of lakes. And so you'll see in the study area there are 6 lake districts: the Noatak, Kobuk Delta, Selawik, Canute, Minto Flats, and Yukon Flats that are entirely in the study area. And then there are 2 that are on the southern boundary, the Tetlin and Kayakuk. And these are interesting when you look at the distribution of, for instance, these large connected lakes. I mentioned over 5,000 in the study area, and over 50% of those are located in the lake districts, even though those districts only make up about 10% of the study area. So they're definitely areas where there's a higher concentration of lakes. These are the connected small lakes. So these are also lakes that are connected to the stream network as defined in the National Hydrography data set, but these are lakes that are smaller than 0.1 square kilometer. There are almost 40,000 in the study area, and about 1/3 of them are located in one of the lake districts. So for the stream network, stream size, large versus small streams, was defined as based on Strehler stream orders. Small streams are 1st and 2nd order, and large streams are 3rd order or higher. And stream order and other reach attributes are not currently attributed in the National Hydrography data set, so we developed a synthetic stream network using tau DEM and the 60-meter national elevation data set to attribute stream order to stream reaches. One thing about this is we had to process a slightly larger hydrologic area so that we could accurately attribute stream order within the study area. So we extended the study area to include all watersheds that drain into the study area. So I'll call that the hydrologic area. And I'm going to show that to you on the next slide so you can see the actual area that we processed. And this is a typical, this is Model Builder that is provided with the tau DEM add-in, and so it's a pretty standard process for building streams off of a DEM. If you're not familiar with it, you take the DEM and you fill the pits, and then you calculate flow direction, contributing area, and then you use all of that to create a stream network. One tricky part of creating a stream network from a DEM is deciding how you initiate headwater streams, and so tau DEM uses something called drop analysis. And it's based on a geomorphological principle or observation where Strehler stream orders exhibit what's called a constant drop. So if you look at 1st order streams and their mean elevation drop between the top of a stream to a bottom of a stream, that stream drop, if you look at the mean across all 1st orders, should be constant with next 2nd order streams. There shouldn't be a significant difference in mean stream drop. So it tests different initiation thresholds to make it so that it's a constant stream drop. Anyway, so we use that built-in method for defining initiation of streams in the stream network. These are the large streams, and if you look at the inset map, you can see the hydrologic processing area that I was trying to describe earlier. So basically we took all the southern tributaries, for instance, of the Tanana River, and made sure to include all of those watershed areas so that the Tanana and all of its tributaries had stream order attributed correctly. Same thing for some of those southern tributaries of the Yukon. And then we also took some of the Yukon tributaries into Canada, their upper watersheds, but not the entire Yukon. But pretty quickly, because of the processing area, I think the Yukon comes in as, you know, I couldn't tell you exactly, but I think it's like a 5th or a 6th order as it enters the study area. And that's just because of processing limitations in GIS to get the whole Yukon watershed was not feasible. So there are 48,000 kilometers of large streams in the study area. And small streams, this is a map showing all of our 1st and 2nd order streams. There are 140,000 small streams in the study area. Does anyone have questions about the coarse filter conservation elements and how we're defining these 4 aquatic habitats and the methods that we used? Okay.
This is Shelley. What is the date of the source data for those lakes?
You know, Shelley, I'm not sure exactly when the NHD was built, but my understanding of the NHD is that it's based off the original topographic maps. So I would guess that those lake areas are not accurate, in that, you know, lake margins have changed in the last 50 years. It would not show that.
Okay.
As far as I know, and I don't, we are, you know, probably many of you are familiar, we are updating hydrologic data across the state. In some areas it is available based on the new IFSAR, but as far as I know, the last time I looked at the IFSAR map, we do not have new data yet for interior, but those of you that work in interior, maybe you're more familiar with regions that may be updated at this point. Okay, so these are the 6 aquatic fine filter conservation elements. These are 6 species that were chosen by the AMT working with Leah. Chinook salmon, chum salmon, northern pike, dolly varden, and 2 whitefish species, sheefish and humpback whitefish. 2 of these fish species were determined to be data gaps, northern pike and humpback whitefish, just because of lack of data that could be used to define their distribution. There are 3 species that are anadromous, and their distribution will be coming from the Anadromous Waters Catalog. This is the first one. So this is chum salmon distribution from the Fish and Game's Anadromous Waters Catalog. So I'm showing the blue line is the complete extent of their distribution in the Anadromous Waters Catalog, but then I've also got layered on top, pink is showing their spawning or known spawning locations. I thought it was interesting that you know, showing quite a few tributaries with presence of chum, but not identified spawning habitats. So I think we can just presume that either, you know, they're older nominations where they weren't attributing spawning habitat at the time, or potentially there's even higher distribution where spawning is occurring, because chum don't have a freshwater residence time. They're going to be emerging and swimming downstream. So somewhere in some of those major river systems, like I highlighted there, Beaver Creek and the Tolovana, we can presume that there's spawning habitat that's in that area probably already identified. Also, just something to note, so this study area includes both summer and fall runs of chum. Pretty much fall runs are all the Tanana tributaries that we're looking at. Some of the summer run is the southern tributaries feeding into the Tanana, but we don't have those in the study area. So pretty much the Tanana and then the Yukon above the Tanana confluence is all the fall run of chum, and the Kayakuk and below that confluence would be summer run of chum. And there are 13,600 kilometers of chum salmon habitat in the study area, and about 4,000 of which are identified as spawning habitat. But like I said, it seems like it must be much higher since there's so many river systems without spawning habitat identified. I can just close this. So this is Chinook salmon distribution in the Najamus Waters catalog. There are about 13,000 kilometers of Chinook salmon habitat identified, and 2,800 of that habitat, 2,800 kilometers, of that habitat is identified for spawning. Also just did a little bit of digging to try to understand, how accurate this representation was, and Fish and Wildlife Service recently did a study, or in 2011, I guess not too recent now, where they were looking at the origin of rearing Chinook juveniles in some of the upper Yukon tributaries, and they found, this is a couple-year study in 2006 and 2007, they found that 88 to 100% of those Chinook juveniles were actually originating in spawning habitats or natal streams out of Canada, which was a very interesting finding, but it made them go on to conclude that we should probably be surveying for additional rearing habitat for Chinook in these U.S. tributaries, just because there's not identified spawning habitat. They're obviously, because it's such a long downstream migration, they're obviously spending that winter in freshwater part of the way down the Yukon. So this is probably an underrepresentation of Chinook rearing habitat in the Yukon especially. The third species that comes from the Najamus Waters catalog in terms of its distribution is sheefish. This is showing 3,400 kilometers of sheefish habitat identified in the Najamus Waters catalog, and there are 3 identified spawning areas, which total 181 kilometers. Those 3 spawning areas, 2 of them are in the Kayakuk drainage. One is on the main stem and one is on the Alatna River. And then there's also a long spawning location on the main stem Yukon River just above Fort Yukon. Reading in the literature, there's also 2 identified spawning locations in the western part of the study area, one on the Kobuk and one on the upper Selawik River that are not mapped in the Najamus Waters catalog or attributed as such. And I guess I can maybe work with a fish biologist if we have some need to be showing effects in the integrated analysis on spawning habitats. I can certainly contact Fish and Wildlife Service biologists to see if we can identify or map those 2 spawning locations. So this is the one resident fish species that we were hoping to include a distribution map for. At this point, I'm showing the 2 river systems that have anadromous populations of Dolly Varden, and they're in the, that is documented in the Najamus Waters catalog, so that's the Noatak and the Kobuk rivers. And we'd also proposed developing a distribution model for the resident form of Dolly Varden using presence data from the Alaska Freshwater Fish Inventory from Fish and Game. Unfortunately, that I've turned up not a whole lot of data, but some. We had 43 presence points from the AFFI, and then I went through some historic AWC nomination forms to see if there were other observations of resident dolly and came up with another 28. And so now the question is whether or not that's good enough with a balanced data set. So then I grabbed, this is how I've done this in the past, to locate absence data points. I've grabbed projects from the AFFI who were targeting the entire fish assemblage. So from there, when all of those sampling sites where they didn't identify Dolly Varden, I can use as absence points, and then I just randomly grab a balanced subset based on how many presence points I have. So this is showing data that we could use to try and develop a statistical model for Dolly Varden distribution. It's about 140 data points, and maybe we can make that a little bit higher if BLM has a little more observation data we could use. You can obviously see it spatially clustered, along roads in the region. So that was one question, Bob. I don't know if you've had time to talk to other fish biologists and think about that, if you feel like that's a large enough data set to develop a distribution model, or if you'd prefer to just call it a data gap. Or if other folks on the phone have any input, I'd appreciate that as well. And I could certainly, I have more slides here that discuss the statistical model that I use, the method, random forest, for developing these distribution models, if people want to hear more about that. I don't know if the method necessarily deals with the sample size issue any more than any method would. But yeah, I don't know if folks have thoughts on this size data set for developing a distribution model for Dolly Varden.
This is Cindy. I just had a question. Is that random forest data model, is that the same modeling that they've used for the gap analysis? And I remember Tracy's often brought up those gap distribution maps, but were those terrestrial only?
Yeah, Tracy hasn't done fish distribution, is my understanding. And I think is Jess, are you on the phone?
Yeah, I'm here.
What do you guys use?
Well, Tracy did after the AK Gap program, she did birds and mammals across Alaska.
Uh-huh. And was that Maxent, or was it?
Yeah, it's Maxent, sorry.
Oh, okay, yeah. So it's different, Shelley.
I will say, this is Jamie, the random forest is used for newer gap modeling efforts, though. Like California Gap has been reusing the classification regression tree method, so yeah, it's definitely been done a lot for distribution models.
Cindy, does that influence how you envision us developing these models?
No, I was just curious and trying to put some things together that it sounds like I shouldn't have been.
Bob, are you on the phone? We were just wondering if you had thought about the Dolly Varden sample size issue.
Yeah, Bob here. You know, now that I see how many points you have, it looks like we're in the, still under 100. And I know we probably have an extra, I'm just going to guess, 15 to 20. I'd have to really look it up to add to that. So it may very well be worth doing it. I don't, ours are scattered. I think the data points we have are concentrated down in the Tzitna River drainage and between there and Dalton Highway.
Okay.
So it looks a little different, perhaps, than what you have on the map here.
Yeah, and I guess one thing I would add is what I did for Bisley, for Pike, we only had about 300 when you have a balanced data set. So I guess we were upwards of 100 for presence data. But, yeah, I mean, I think we just have to accept that these are pretty coarse. With the Bisley model, for both Dolly and Pike, we're able to get what I called a spatial cross-validation accuracy in about 70%. And so that's basically saying, it's this idea that you're predicting into these areas where you really have no data to build the model. And so what you do is you pull out data that's spatially clustered. So I could pull out that northern Dalton Highway data and pretend we didn't have it. And it just gives you an idea of what your accuracy is of predicting into areas where you had no data to inform the model. So Bisley was a little bit more spread out, and I could build those spatial clusters pretty well. And for Dolly, for instance, we had, I think, 600 data points into that spatial cross-validation. And, yeah, again, it's still in the realm of 70%. I just don't think we're going to get much better until we get better hydrology and more of these historic data sets come online. That's going to be the quickest way to get better data and more data to improve this kind of modeling effort. But I guess one thought too, Bob, is just like, maybe a gut feeling about how different potentially, resident dolly habitat is, and just being more familiar with streams in interior Alaska, which unfortunately I'm not. How different these streams are, and by, having a lot of data in this Brooks Range foothill area, and or just along the Dalton, if that's going to be representative of further west or east in the study area where we're missing any data.
I can't speak for anything in the east. We did some looking back in, it's been 10 or 15 years ago, and did not find many Dolly Varden in the eastern part of the state, Fort Yukon, south through just northeast of Fairbanks, say. So most of the data we have, or instances that I know of where there are Dolly Varden, would be along the Dalton Highway, down through the Nowitna drainage, and we certainly found a number of them along which it would be akin to the Bisley study, but on the east side of the Yukon, on the west side of the Yukon River, and the drainages like the Nolato, Gasasa, on down through Anvik in that area. Sure. So we have a fairly, spatially we've captured dollies near the headwaters of, on the north side of the Alaska Range and the Nowitna, and then of course up along the brooks. So it's not truly representative, but I think it's a fairly good geographic representation.
Okay. Okay, well, Bob, maybe I'll follow through with you and we'll see how much bigger we can make this data set and just make sure to include any other fish biologists you think would be interested in a very final decision. Does that sound good?
No, I think that's a good idea. I know Matt Varner wasn't able to sit in on this conversation today.
Okay.
And I know he'd like to look at the presentation, and I know he and I would like to sit down and discuss it further also. So perhaps what I can do is look up those data points that we have and add it to this and then see where we're at.
Okay, that sounds great. Okay, well, so that's all I had for distributions. I had more slides if people are particularly interested in the random forest method, just describing it, and I'd be happy to go through those if that's of interest. Or if, this might be a nice time to pause too, if anyone has questions about any of the distributions I've shown so far.
So this is Shelley again, and I missed this morning's presentation, but when I was looking at the maps the map that you last had on the screen, I'm curious about what our study area is. I was remembering that we ended up getting into the Kobuk River drainage sort of by virtue of the fact that we had agreed to go one HUC unit above what we had thought was our study area so that we would have overlap with the other areas. But it doesn't seem like we did go one HUC above it, unless I don't know how to read the geography of the map, but it doesn't look like we lapped over like onto the north slope, for example, to overlap that area, right? We're on the south side of the Brooks Range with that northern boundary. And then same thing, I don't know if that lower line is the Alaska Range. It looks like it's just shy of it. So I'm just wondering how are we capturing so much of the Kobuk River drainage in this RIA and not as much overlap in the other adjacent?
Jamie, do you have an answer for that?
I'm trying to think about. Well, I mean, it's just the 7 ecoregions that we all decided on with the one HUC buffer, and so I guess I'm not totally understanding the question. Yeah, I'm not totally understanding the question, I guess. I mean, the Kobuk was included as part of the ecoregions, but again, we're not following the HUCs as the broader landscape unit. It's really just those 5th level, which don't really correspond to major drainage systems, that are buffering beyond the ecoregions. So maybe.
So Jamie, but on the north side of the study area, didn't we cut it off at the crest of the Brooks Range south?
We did, yeah. So the northern part is cut off right at the crest. Sans that little blip up to Tulik, because that was specifically requested to include that part in the Dalton corridor.
Right. So that's one of the things that struck me is because that does go over the top, and you can see, and there's gobs of dollies up there, right, in those little lakes up around Tulik, and you can see a little bit of that, but it doesn't capture that whole area like it does when you go over to the Kobuk side, you get all of that drainage out to the ocean, but we don't see that on the north except just that little bit as it overlaps, I guess, into Tulik.
Right, yeah. So that was created after we did our first boundary. You said it really makes sense to consider that part of the Dalton as part of the planning area, or within this planning area, and so we included it. And I can't actually remember if we used 6th level HUCs or 5th level HUCs to kind of just buffer out into that, because I feel like the 5th level HUCs were really quite large, and that would have created substantial overlap with the North Slope REA. And so I remember there's an awful lot of back and forth on what accurately included or appropriately included enough of the BLM lands on that little spigot going north. But yeah, that was the justification then, but it wasn't really in respect to capturing that hydrologic connectivity.
Kind of, but
yeah. Cindy, do you remember it? I mean, I feel like I don't actually know who we went back and forth on with, why we included just that smaller piece.
Isn't the case that the streams shown on there are from the anadromous streams catalog? So those are anadromous dollies, and that's why the rest of the streams aren't showing up on there. That's only where anadromous dollies occur. Is that correct?
Yep.
The document.
Yes, that's
okay.
right.
So I think that's part of what Shelley's asking. Why doesn't the rest of the Kayakuk drainage show on there when we know there's dollies in it, but they're not anadromous?
I got you. Okay.
Oh, I'm sorry, I missed that. I'm sorry, Shelley. I thought you were asking about just study area boundaries. Yeah.
Well, I kind of was, but that helps. That I think that was part of what was confusing to me.
This is Cindy. So Jamie just confirmed on the boundary question, these two RIAs will overlap, correct?
Mm-hmm. Correct.
And the problem, I mean, I know the overlap is there so that they can be compared, but a lot of the folks from the North Slope RIA were actually kind of complaining that there was one huck on the southern side of the Continental Divide because it was throwing off some of the modeling for the North Slope. So it'll be interesting to see between these two RIAs whether this overlap was really, I mean, I understand the Tulik area and why we bumped up for that because there's so much BLM managed land, but in these other areas, whether that overlap will actually prove to be useful or not, because there is such a difference just from the southern to the northern side of this mountain range.
Yeah, that's a good point. Yeah, it will be interesting. Putting it all back into context of the broader ecoregions. Cool.
Was there anything, Becky, with the boundary that you thought looked a little bit weird with the CE, thinking about the watershed being extended into kind of along that Dalton Highway little thumb there? Does it cause any major ecological?
Oh, yeah, no, not that I can think of.
Yeah. Cindy's right that people, with the fire analysis for the North Slope, it kind of skewed some of the statistics because it all was kind of encroaching on the boundary and not necessarily reflective of the North Slope as a whole. So, yeah.
Well, yeah. Those are Arctic dolly. I guess that's the only thing. Dolliers are going to a totally different marine system, but yeah. Okay, thanks everyone. If there aren't any other questions.
Yeah, thanks all to those on the phone, and tomorrow we have 3 more webinars, and we did record this one because I know Matt Gardner wanted to listen to it, and we'll post the recording, or send the link, I guess, of where you can access the recording so that you can listen in, and others that are interested. And we'll also record the ones tomorrow. So thanks all, and feel free to email Becky or myself with any questions or thoughts if you have them later.